Okay, up next we have Tyson Clugg. Tyson Clugg has been hacking Django since 2007 alongside Django core developer Curtis Maloney. Tyson worked with Curtis on security-critical infrastructure, including the access control system developed for the Melbourne Cup, which was subsequently used by Ticketek. These days, Tyson can be found working for New Atlas, either drinking coffee, eating banh mi in Collingwood, or relaxing at his home on the side of Mount Dandenong.
Hi, thanks. I'm Tyson. You can find me on Twitter, Tyson Clugg. Obviously, I'm at New Atlas, and we're not big, we're not Google, but we are in the top 1% of websites worldwide, especially in the United States. In fact, I think at the moment we're rating about number 2,500, which for the United States isn't too bad for our ranking there. There's not going to be any Q&A. I don't think we're going to have time. So if you go into the Slack channel on PyConAU, #Ludicrous, you can find that I will put the entire talk up there, upload it there. So you don't need to go and take screenshots or whatever, no photos necessary. Yeah, we'll go chat in Slack afterwards. And also immediately after, I'll be available to talk outside as well. So the purpose of this talk is all about latency. Latency is such a critical feature to making your website or application high performance, and it's quite different to bandwidth. Bandwidth measures how much data you can transmit over a period of time, whereas latency measures the delay between when the signal starts being sent and when it arrives. For optical and electrical networks, it's essentially the speed of light, although over copper it's only 2/3 the speed of light. And to give you an idea, 1 nanosecond is only about this far. So if you even go from one machine to the next in a data center, like literally across to the next machine, chances are you're going to go that far. If you're talking about across a data center, where it might be 300 meters within the same data center, then chances are it's going to be more likely 300 meters. And if you've ever installed Cat5 or Cat6 network cables and you get that 300 meter roll of cable, that is 1 microsecond of latency that you're holding. It's actually 305 meters, but close enough. And if you're talking about 1 second, you can go around the Earth 7.5 times in that sort of period. So if you're experiencing latency issues like that, you're doing something wrong. And that's what we're going to talk about today. So let's have a look at some quick scenarios that might explain it. Alice wants to send 36 gig of data to Bob. And it might be all the Game of Thrones episodes, or it might be TPS reports. We don't know. But there's different scenarios here that you would use high bandwidth versus low latency in different ways. So let's talk about that. Why is my slide not advancing? Because my focus is elsewhere. So, scenario 1. Excuse me. There we go. Scenario 1, avian carrier. We want to send 36 gig of data, 10 kilometres. So avian carrier, if you're not aware, is carrier pigeon. So we're going to send a USB stick via a bird. Now the USB stick, of course, can take a lot of data, but the bird is going to take a little while to take it there. So it's got a 20-minute round trip time. It has a TCP handshake. If you're using TCP with this, it's going to take a while. It's going to take you 30 minutes to send the data. You've got excellent bandwidth available, but the throughput is diminished because of the TCP handshake before you can actually send the data. And the first packet of data arrives after 30 minutes, as does the last. So too much latency if Bob wants to start watching Game of Thrones right now, but it's great if he can wait. And it's fast enough for Bob to finish his TPS report in a few hours, if that's the sort of time frame he's got. Scenario 2, we're talking about NBN here in Australia, and their basic fibre to the premises, which is actually somewhat fast, 36 gig of data is on their basic plan, only 1 megabit per second. The 66.7 nanosecond round trip time is actually quite good. So it's less than a millisecond, so the ping times are quite good, but the bandwidth is quite low. So the TCP handshake, that's all fine. We can do that in 100 nanoseconds. We can send 36 gig of data in 10 hours. That's a lot slower than our avian carrier in this instance. So, the old sneaker net's pretty good in terms of throughput, but latency, it's horrible. So we get very good throughput, but it's too slow if Bob wants to finish his TPS report and get it done before close of business today. It's low latency, so he can start watching his Game of Thrones episodes like right now. So that's pretty good. Latency on the web. When you're actually talking about latency on the web, there's lots of different sources of latency. Now, we talk about different parts of the application stack here, and the very first thing that's fundamental to any web communication is CCP. So you need to do a DNS lookup. If you're going to newatlas.com, our website, where you can get some amazing news, then you need to look up newatlas.com, get the request, get the response. Perhaps you need to do some verification of your DNS responses as well. Then you go through the TCP handshake again, and eventually you end up with a connection, a TCP connection. The next layer is more likely going to be that you're going to have to do a TLS handshake. So the TLS handshake is going to take more time again. There's client hello, server hello, certificate verification, and all the other steps. Now, interestingly, there's actually a point in here where you can do some further optimization with the OCSP responses. If you get the certificate done in such a way that it includes all of the information that the client will need to verify your certificate, you can make things go faster again. So this is, before you've even got to Django, you've got all of these other things that can cause latency for a visit to your website. So let's keep going. So then we get to HTTP. You finally got your TLS connection, because these days it's like not many people are using unencrypted stuff. And we start talking about the HTTP request. This is really interesting because request headers are probably the first thing that happen. And request headers include things like cookies. If you have an excessive amounts of cookies or very large cookies on your domain, then they get sent with every request. And the problem is that that means if you're on, let's say, a mobile network, that all of that data has to get sent before you can start getting the response. And that's just going to slow things down. So this is where they talk about cookie-free domains for some requests. Once the request actually arrives, then you've got the server processing and various things that Django will do for you by default in the middleware. So sessions, for example, typically if you're using file-based sessions, it has to go off to disk and read from disk. You could be using cookie storage instead. That means that it doesn't have to go anywhere. It's got all the data it needs in your cookie. Auth, so the auth module in Django, it has to go off to the database and read your user and say, oh yeah, this is Tyson and he's an admin on the site. And I'm going to stick that onto the request as request user. Sites, if you're using the sites framework, once again, you have to go and look up number one to find out what your site name is and confirm that it exists in the sites table, and go and stick it onto the request as well. Compile templates, application queries, there's all sorts of things that go on in Django before you've even got to your view code to then process the response headers in the body. So subsequent HTTP requests, you've just done your first request for your index page, and then you've got to go and get your scripts, your style sheets, your images, and all the other bits and pieces that make up your application. So surprise, surprise, there's more stuff to be done. And if you took, let's say, 300 milliseconds to get that initial page out, and then it's like, oh yeah, but you need these other resources to show the page, then if you haven't responded for 300 milliseconds, that's another 300 milliseconds people have to wait. HTTP 2 goes some way towards addressing some of these things where you say, like, here's my initial page, and then the browser's figured out that it needs to go and request your style sheets and things. So it allows many requests in parallel for a start over a single TCP connection, which means you only have to do that one TCP and TLS handshake, which we saw can be a significant source of round trips. So that's important. And it can help reduce latency of subsequent requests by guessing which resources the client needs. hey, you've requested our index page, you're probably going to need our JavaScript bundle, you're going to need our CSS bundle, and here's a couple of images that you might need as well. That can be a bit problematic though, because of course, incorrectly guessing what the client needs and saying, hey, you're going to need this, that, and that, might be completely wasteful if they've already got those in their local cache. So, oh, fun. Django streaming responses, I'm just going to open this up because the last one's appeared anyway. Streaming responses are good because in terms of latency, when you attempt to send back responses, rather than saying, I'm going to build up the entire response and then just shove it down the wire at the very end after I built it up, it's quite inefficient. So it's actually better to get whatever data you can get out immediately. So let's say you've got, I don't know, let's say you're downloading a CSV report for some big application. So rather than loading that all into memory, number one, consuming lots of server memory, you can do a streaming response where you say, I'm going to read the data from the database, and as I get the first row, I'm going to stream that out and say, here's row number 1, here's row number 2, and keep going. So Django lets you do that within a view. You can actually say that your response content is a generator expression. So you can then just yield strings, which is really cool. I'm not going to go into too much technical detail about any of these particular steps. The goal here is just to open your eyes to some of these points of latency across the entire stack. All right? If you've got any particular questions about technical implementation, jump on #Ludicrous in Slack and we'll talk about it there, or just outside after the talk. There's some issues with streaming responses though. So number one, you can't change the response status after you've already sent it. HTTP, in your responses, the first thing that happens is that you respond with 404 not found, or 302 see other, or in this case 200 okay, and you start sending your data back. But then if you get halfway through and you encounter a row that causes your Python code to blow up and you have an exception, there's no way to go back and say, actually, sorry, it wasn't a 200 okay, it was a 500 internal server error. Perhaps one day someone is going to see the light and HTTP3 will allow us to change the response code after the fact and say, actually, sorry, that wasn't 200 okay, that was 500. So maybe one of you guys will help work on that. The other thing is, in Django, if you're using template response as the view, there's no streaming equivalent of it. I'd like for that to change, so maybe we can do something about that. All right, caching. People have talked about various things in terms of making sure that your view returns data in a quick manner. And the first thing that comes up is caching. It's like, well, let's not do this big database query. Let's instead just stick it in cache and go and get the data from Redis or whatever it happens to be, or memcached. So it lets you keep the result of expensive things, like a big fat database query, in a more local location. It exposes you to one of the two difficulties of computer science, of course, which is always a trick. The bigger issue is that most projects use a single central cache server. So we talk about the function of distance, and you talk about across the data center being 300 meters, or if you're talking about using Amazon, and if you're in their US East 1 Virginia data center, it's actually not a single data center. It's a collection of data centers all across Virginia, and the reality is that any two of those data centers at best might be 10 kilometers apart. Realistically might be a lot more. So if you're saying that your web server in one particular data center is then talking to a cache server, even in the same region, it's not particularly good for cache locality. That means to say that the request has gone off to the cache server and it comes back. It could be coming back 100 milliseconds later or whatever it happens to be, depending on what's going on. Particularly bad if you're talking about a cache server being on the US West Coast versus the web server being on the US East Coast. It happens. So you better to use what's in Django as the lock mem cache where appropriate, where you actually have, within the same Python process, ability to cache some data. So that means that you don't have to go out across the wire a long, long way. Check out Django utils cache for some neat helpers on that. Template fragment caching. So when you're rendering a template in Django, you get opportunity to do all sorts of funky things, and you can put your template logic, all sorts of cool stuff. The best thing that you can do is start using the cache template tag, and there's actually an advanced version of that you can use as well, that another project provides. But it gives you the opportunity to wrap up lots of different API calls in one cache hit. So rather than, hey, give me this data from the cache server, or now give me the next piece of data from the cache server, now give me the third piece of the data from the cache server, it says, just give me all of this in one hit. So you're only doing one round trip. Once again, round trips, I guess you could say the number of trips that you do across the wire to a remote location, that is the primary thing, like you're going distance to get there. So you want to reduce those round trips to try and reduce the amount of time that you're spending on caching. So templates and template fragment caching, it only really works if you're using lazy context. So we'll go into lazy context in a minute, but it's really, really important. The Django add cache tag provides a no cache tag and also provides an improved implementation of the cache tag. So I'd suggest you go and look at that package. So lazy evaluation. The fundamental idea is that you don't do any calculation until the last possible moment when you know that you need that data. So you don't go and pre-calculate something and then stick it in the context from your view. Instead, you provide maybe a link to the model of instant that you need, and then say, in the view, give it the ability to calculate that logic, perhaps via a template tag or otherwise, so that you are not performing that expensive calculation or expensive database lookup, whatever it happens to be, until it's absolutely required. The cool thing is, of course, that if you don't need to call it at all, perhaps because the information is being cached at a higher level, then you haven't wasted any time doing the calculations or retrieving the data. Django query sets are lazy by default. Take advantage of this, as long as you don't force evaluation of them early, that is. So when you hear about Django query sets being lazy, that means that you can essentially, if you can say, here, define my query set as blog objects filter date equals today, it won't actually go and do the database query until you loop through those instances, for example. So part of lazy evaluation part 2 is that Django internally gives you this really neat thing where where are we? So here we can see that in our context data, you can push things in, but normally we'd have query count. To actually get the count, you would actually call it with parens and it would give you the value. But Django in its templates, when it sees a callable, it will call it for you, which is really cool because you can just provide it as required. Go and have a look in Django utils functional for some really neat helpers regarding all of this too. So, query set optimization. Your query set itself can be optimized to reduce latency. Select related and prefetch related can help you avoid more round trips to the database server. So go and have a look at the documentation for those two things. Use annotate and aggregate where appropriate to go and get the database to do the work on counting things, on doing whatever it happens that you need your view to do. Use Django debug toolbar to keep an eye on exactly what queries you're running. If you can't see what's going on, there's no way you can optimize it. We'll come back to that in a minute. use test case assert num queries to ensure that you don't fix something only to have someone do some work on it a bit later and then unfix it for you. Right? So you can actually go and check to see that the work that you did is being maintained and that you're not all of a sudden causing things to go nuts later on. The final thing is consider denormalization of your database schema to put the data where it's needed. So that means that you might, for example, for an author, put the total number of articles that they have, blog posts or whatever it happens to be, on the author table itself, so that you don't need to actually go and count them every time you show, this author has 200 posts. Or perhaps you don't even show it at all. So a quick recap. Latency is primarily a function of distance. A faster router, CPU, whatever it happens to be, won't help much. Right? Bigger bandwidth won't help. Latency is a function of distance. You avoid round trips to reduce latency. This is really important. So every cache request that you make, every database request that you make, every API call to an external service that you make is going to affect your latency. Analyze your whole stack looking for issues. Right, we're talking data center level, like don't put your cache server on the opposite end of the continent to your web server. Use streaming responses where appropriate. Don't wait until you've done all of your processing before you start getting that data to the client. Cache aggregate results, as in to say, don't make a cache request for every little thing along the way. And a common thing that I've seen here too is people using things like database query level caching, where they say, hey, I'm going to do this cool thing. It means we don't have to go to the database every time. We just go to the cache server instead to try and get this data. But often that means that they end up going to both anyway, or that they do it in a poor way. Adding lots of caching at different things isn't necessarily going to help. Adding caching willy-nilly without actually thinking about what you're doing is a bad thing. Sometimes it's actually better to remove layers. Be lazy. So obviously, don't calculate any data until the last possible moment when you have to. All right? So Django provides some cool things to do that. Use it. Measure using Django debug toolbar, New Relic or otherwise, and then optimize. There's no point in jumping in and getting your sleeves up and going, right, I'm going to optimize everything if there's no actual value in doing so. Find out using whatever profiling tools you've got. New Relic is actually really good for this one because it lets you drill down to like your cache server requests, your database server requests, API calls and other things as well, and it shows you which things are going slow. So I recommend that. Once you've actually measured, then optimize as appropriate. And don't forget, use things like assert num queries so that you don't break it again in the future. So what about ludicrous mode? Why is this Python ludicrous mode? Well, most people still think about speeds in terms of bandwidth, start thinking about latency, take a high-level look at your algorithms, and don't do ludicrous things such as query the database and then not use the data. Project Ludicrous. On Monday, at the sprints, I'd love to start working on streaming template response within Django. So I'd love for people to help me out with that. HTTP 3, maybe that someone can get on the working group, anyone who's got some influence there, and actually have late status codes. That'd be pretty cool. So we could then say, sorry, that didn't work out for our streaming response. Let's change the status code. Thank you very much. NewAtlas.com is one of the top 1% of websites worldwide. Maybe you want to work with us on our team. It'd be lots of fun. Maybe you just want some help with your current stack. Come and talk to me. I'm on Slack in the hashtag Ludicrous channel on Slack. My nick is TC, and I'd love to see you around. Thank you. I'll take a couple of quick questions, but we don't have much time. I'll also be available immediately after the talk just outside the door. But obviously, I expect that you will all go off to another talk. I'll be available again from 1 o'clock until 1:30 on the channel. So, and I'll be around as well. Any questions?
With regards to cache invalidation, do you tend to send signals from the source of the change to other servers to tell them to renew the entries in the cache, or how approximately does that work?
For newatlas.com, we've actually got a novel approach where we use the xmin system column of Postgres, which refers to which transaction that row became visible in. I hope to release this as an open source thing and talk about it in the future. But it means that cache invalidation for us and having to worry about exactly how that works is largely a thing of the past. Come and talk to me if you'd like to learn more.
Thanks.
Great talk, Tyson.
Thank you.
Just quickly, I didn't see it in the slides, but the part of the stack, the whiskey server and the reverse proxies and that kind of thing, just maybe a couple of ideas around that? Or?
Sure. So obviously, if you're talking about AWS, which is what New Atlas is running on, then you've got opportunities to, for example, have multiple application server gateways or and then talking to your backends. So make sure that they're in the same data center is a good start. Consider if you actually really need them. It is generally a good idea, but sometimes for some applications it might not be a good idea. It comes down to your particular application, your use case, your user base, security needs and otherwise. But certainly, just number one, making sure at least that they're in the same data center, not attempting to say, you know, put your front-end ASGI, your front-end application gateway on the opposite side of the country, for example.
Any more questions? No, I think that's it then. Tyson, on behalf of PyCon Australia, I'd like to present a small gift for your amazing talk.
Thank you very much. Woohoo! Yeah. All right, I look forward to seeing you all afterwards. Thanks.